Hello students, welcome to Smarter Engineer. Today our topic is RGB and CMYK color model. So before starting, what we should know from this lecture series? From today, we would know what is RGB color model, how we can implement this RGB color model, and where we can use this model, and what is CMYK color model, how we can be benefited from this color model, and what is the relation between these two color models RGB and CMYK, and also what are the advantages and disadvantages of or the differences between these two color models. Okay, let's start the session starting from RGB color model. RGB stands for red, green and blue. Red, green and blue color model. Okay, this is an additive color model. What does this mean actually, additive? I will discuss later, but first suppose along x-axis, y-axis and z-axis. Along x-axis we have represented the red color. Along y-axis this is color green, and along z-axis this is color blue. So if we want to represent this RGB along x, y and z axis, then we must say, we know from our previous class that 0 means off, signal off, and 1 means signal on. Please keep in mind that 1 means on and 0 means off. Now, from this block or cube, which point is totally visible or in front of your eyes? Which point? This point. This point is totally visible. So we can say this point's coordinate is 1, 1, 1, or this is white, because this is totally visible in front of your eyes. And which point is totally invisible? This point is totally invisible, you can't see from front side, that is black, and 0, 0, 0. Okay, now starting from 0, 0, 0, that is black, when all the signals are off, 0 means off. Suppose I want to show only red color. Okay, then red must be on means 1, and green and blue must be off. Clear? Now suppose I want to show green color, that means red should be off, this is on and this is off. And for blue color, yes or no? Now if we mix red and green, then we get this. This is actually yellow color. Red and green must be mixed, so red and green must be 1 and blue must be 0. So the coordinate is 1, 1, 0. Clear? Now similarly green and blue from green and blue we get this point, and this is called cyan. Green and blue must be 1. So the coordinate is 0, 1, 1. And blue and red gives us this point. This is called magenta. And coordinate is 1, 0, 1. Right? So this is our total RGB color model, and obviously at last 1, 1, 1, that is our white. So this is our RGB color model, from where starting from 0, 0, 0 we are going to 1, 1, 1 by summing up or adding up. That's why this is called additive color model. We are actually adding two colors, red and green to get yellow, green and blue to get cyan, blue and red to get magenta. Okay, and whenever we are mixing red, green and blue together, then we are getting white. We are adding red, green and blue together to get 1, 1, 1. Okay, now here is a question. There is an axis between these joining points, that is black and white. This axis is called gray axis. So whatever the value between 0 and 1, suppose the value is 0.99997, so this point or must lie within gray axis hour. This is called gray axis. So what is gray axis? The axis joining black to white, that is 0 to 1, 0, 0, 0 to 1, 1, 1. This is called gray axis. Clear? So this is our total RGB color model, from where we are getting the value by adding. Okay, similarly in case of CMYK color model, CMYK, cyan, magenta, yellow, and K stands for actually key color. K stands for key, KEY. Cyan, magenta, yellow and key. Here key color is nothing but black, and CMYK is subtractive color model. RGB is additive color model. This is a subtractive color model. Why subtractive? Because we are getting this, we are getting the colors from CMYK by subtracting the value from white. From white we are subtracting. Okay, you can draw similar picture for CMYK also, like this. Where this is cyan, this is your magenta, and this is also yellow. Here this point is black and this point is white. Okay, from cyan and magenta we can get this point, and this is blue. From magenta and yellow we can get this, and this is called red. And from yellow and cyan we can get this, this is called green. How can we get this? Actually here white is 0, 0, 0 and black is 1, 1, 1. How can I get this? We are getting this like magenta is equal to white minus green, cyan is equal to white minus red, and yellow is equal to white minus blue. Got it? So this is a subtractive color model where we can get the color from subtracting from white white minus green, then we get magenta, white minus red, then we get cyan, and white minus blue, then we get yellow. And K is the key color which denotes actually black here. Now, where we can use this RGB and CMYK color model? RGB color model is used, suppose, in where electronic source is best, okay, but CMYK color model mainly used in printing technology to print something. But in our television, camera, RGB color model is much better and this is used. But in case of printing, RGB is not good because this is additive color model. We have to add up to get the new color. That's why RGB is not used in printing. In printing, we use always CMYK color model. Clear? Now comes to difference between this RGB and CMYK color model. But before going to the difference, what is the relation between these two color models? RGB color models is equal to actually nothing but 1 1 1 minus CMY. So this is the main difference. This is very important. What is the relation between RGB and CMYK? To get RGB, we have to subtract CMY from 1 1 1. Clear? Now come to the difference between these two color model. Number 1. In case of RGB color model, the primary colors are obviously red, green and blue. But in case of CMY, cyan, magenta and yellow. So this is an difference. Next point, in case of RGB, the secondary colors are cyan, magenta, yellow. That is, we are just reciprocating our first point. But in case of CMYK, our secondary colors are red, green, blue. Okay. Number 3, RGB is an additive color model, whereas CMYK is subtractive color model. Next, when we add red, green, blue together, we get white. Yes or no? But cyan, magenta and yellow combined is black, the absence of brightness. So from cyan, magenta, yellow we get black, but from red, green, blue we get white. Next point, RGB is used to create image in screen and display. I have already told you, screen and display means, suppose in television, laptop, desktop, camera, etc. where screen is present to display something, then we can use RGB. But in case of CMYK, printing to paper or other media, that is printing purpose, is well handled with CMYK. And what is the next point? RGB color model is ideal for an electronic source, but CMYK is ideal for printing. And next, no additional color is used to remove light in case of RGB. No additional color is used, but in case of CMYK, additional black color, that is our key color, is used to remove any light. Okay, So this is all about what is RGB color model, how we can implement this, what is CMYK color model, how can we implement this, and what is the relation between these two color model and what is the difference. There are total 1 2 3 4 5 6 7 points. This is all about RGB and CMYK color. Hope you have enjoyed the session of learning RGB and CMYK color model. If you like the video, please comment below, share and subscribe. And if you have any query, please ask me in the comment section below. Thank you. Bye bye.